Hello everyone, welcome to Module 5 of the Google Cloud Platform tutorial. Before understanding what we'll be covering in this session, make sure to subscribe to Scalar's YouTube channel so that you don't miss our upcoming videos. And also, if you want to learn different technologies and frameworks from industry-leading experts, you can check out Scalar's masterclasses and they are free, and the link is in the description below and you can go ahead and look into it. Now, let's understand the topics that I'm going to cover in this session. To start off with, I'll be teaching you what exactly is a network because that's the most basic element in this particular case. Because without a network, there is no concept of VPCs. Now, coming to VPCs, it's called a virtual private cloud. We'll come to what it means. Under VPC, there are various concepts. There are subnets, there are routes, there are also firewalls and more. So we'll look into all of these concepts. And also, once we learn them theoretically, I'll show you a demo so that it's even more visible and even more clear for you guys to grasp these concepts. Now, let's get started. So let's start by understanding what is a network, because that is the first concept we'll have to learn, because without understanding what is a network, you won't be understand what are cloud networks, right? So now, what is a network? A network is defined as the connection of at least two computer systems, either by a cable or a wireless connection. To put it simply, if there is another laptop and I connect both of those laptops using a LAN cable, they become a network because they are connected to each other and a network is created. Data can be shared from one computer to the other computer and vice versa. Same thing wirelessly. If I connect this via Bluetooth to another system, a mobile phone or another computer, then in that case, another network is created. I can share data wirelessly, right? So that is also a network. So anything which connects two different computer systems is a network, or two or more, basically. The simplest network is a combination of two computers connected by a cable. That's what I was explaining right now. This type of network is called a peer-to-peer network. There is no hierarchy in this network. So to put it simply, if there are four different computers and you connect every single computer with each other with a cable, that is, let's say each computer has two different LAN cables and you are connecting each of those together. So now there is no hierarchy. Every computer is connected to each other. Any computer could send data directly to its adjacent computer or the opposite one, right? So in this case, there is no hierarchy, and peer-to-peer networks are used in a lot of places. Especially, you would have heard about torrents. It's extensively used in torrents, the peer-to-peer network, to make the downloading speeds faster. Now, each computer has access to the data of the other device and can share resources such as disk space, applications, or peripheral devices. Now, again, there is no privileges, so that basically means any device connected to all of these computers will have equal rights to all of these computer systems. Any computer can use those devices. That's basically it. Now, today's networks tend to be a bit more complex. They don't just consist of two computers. Systems with more than 10 participants usually use a client-server network. In these networks, a central computer provides resources to other participants in the network. To put it simply, in this case, there will be a server, which is the computer which connects all of these clients. Now, the clients would not have communication between themselves. They will only be connected to the server. If computer 1 has to communicate with computer 5, they can't connect directly. They'll have to communicate via the server to computer 5. That is, if you want to send a file from computer 1 to computer 5, then you will have to go through the server. So any decision, any rights, everything is held by the server itself. Server will decide if this computer can print something or use a particular device which is connected to the network. So these were the types of networks. So one is the simplest network, which is peer-to-peer. One is a client-server networks. These two are the most popular and most common networks you would see. Client-server networks are still popular because in most computer systems, they want to connect thousands of servers together. So if you want to connect thousands of servers, then you can just have one server. For example, if you want to update every single one of those thousand servers, by manually logging into each one of them and editing them would be a tough task. Rather, you can basically write it in the server itself. For example, you can update a file in the server and the server will distribute it to all the client computers. So that's where client server comes into play. Now, you've seen what is a network, what is a VPC. VPC is a virtual private cloud. It's a virtual version of a physical network that is implemented inside of Google's production network by using Andromeda. And if you have a doubt what Andromeda is, not the Galaxy, Andromeda is GCP's network virtualization stack. Again, if you want to learn more about this, there's a complete documentation which is provided by GCP themselves, explaining how this entire virtualization stack works. But on the ground level, on basic level, you don't need to know how the backbone of it works. But again, if you're intrigued by it, you can go ahead and learn. They would have explained every single aspect of it. They would have explained what are the different elements within the virtual network itself, right? You can go ahead and check it out. You can just type GCP Andromeda and you'll get the documentation. Now, what exactly does a virtual version of a physical network mean? That basically means there is a virtual network formed in Google's data center, and you are able to view that in your computer. So you are technically using a virtual network which is hosted in some other physical data center, right? And VPC basically it isolates the resource within that particular VPC. So for example, a VPC is a private network, a private cloud within GCP itself. So basically it will create the small bubble. Let's assume there is a bubble, and within the bubble there are so many different elements. So now these elements won't be accessible by the external elements. So let's say there are two bubbles and each bubbles have their own elements. Now these two things cannot communicate normally. There are things where you can make them communicate with each other, two different networks, but that we'll come back to that. But generally VPCs isolate the resources from each other. So for example, if you're creating a compute engine, which we've already learned, a compute engine or a database, and you don't want public access for them, you just want to keep it private, in that case you can create a VPC which does not allow any public access. That is, it does not allow any access from the internet, and you can create these resources over there. And once you create it over there, there won't be any public access into that particular VPC. It isolates those resources, right? So now, what does a VPC network do? There are multiple functionalities. One is provides connectivity for your compute engine, virtual machine instances. For example, when we were creating our compute engine, we did not have any VPC. We did not create a virtual private cloud, right? So without a VPC, you won't be able to create a compute engine, but we were able to create. That's because GCP, they provide a default VPC as soon as you create your account. So using that default VPC, you can still create virtual machines. Next, offers native internal TCP UDP load balancing and proxy systems for internal HTTPS load balancing. To put it simply, there are some internal facing softwares in major corporate companies, right? Internal facing software in the sense, softwares which are only built and meant to use within the company, which are not public softwares. So in that case, you can use it to load balance internal traffic within the VPC itself. Again, that one. Next, third is an on-premises network by using cloud VPN tunnels and VLAN attachments for cloud interconnect. So you can connect basically an on-premises network to a cloud network using multiple things. One is a cloud VPN tunnel, virtual private network. You can use a VPN tunnel in order to connect with a non-premises network and the Google Cloud VPC, or Google Cloud VPC to another Google Cloud VPC, which is in another GCP account. Then there is also VLAN attachments for cloud interconnect. So VLAN is basically virtual LAN. It's basically like connecting your laptop to another laptop using a LAN cable, but virtually. Now, in this case, again, you are connecting to a on-premises network from your GCP's virtual private cloud. And finally, distributes traffic from Google Cloud external load balancers to backend. Now, we already understood what an internal load balancer is. An internal load balancer is basically for software which is within a company. Next is a Google Cloud external load balancer. In this case, an external load balancer is for an application which is public facing. Public facing in the sense that is used by users on the internet. So now, internal load balancer is within the VPC itself. External load balancer is for an application which is public facing and used by the internet. And for that, you can use the VPC to allow traffic from the internet as well, right? So again, for that, you can use VPC. So these are the different use cases of a VPC network. Now, moving forward, Yeah, I wanted to show this comparison over here, that is GCP versus AWS, because again, GCP is important concepts which you'll have to know, because GCP's architecture is different from AWS or Azure's architecture. Let me quickly summarize this for you guys. Let's first understand how AWS architecture works, and then let's come back to GCP. Over in AWS, if you see, this is the cloud computing network. So now within AWS, there are different regions, and within a region, you can see there is a VPC, right? There is a virtual private cloud within a region. AWS, again, there are multiple regions. Inside multiple regions, they have multiple availability zones. So now VPCs are basically throughout the entire region. If you create a VPC in North Virginia region in AWS, it is for the entire region. If you create a VPC for, let's say, the Mumbai region, then it's for the entire region. How many availability zones there may be doesn't matter. If there are 6 availability zones, the VPC would be spread across all of those. Now, within the VPC, you can create subnets, but subnets are specific to availability zones. Like how VPCs are specific to regions, subnets are specific to availability zones. And in this case, you can see availability zone data center 1, availability zone data center 2. So there are two different availability zones, and within two different availability zones, there are two different subnets. And you can see they both have different IP address ranges. Again, if you don't know what IP address or IP address ranges are, I'll come back to that later while explaining that. But now just assume, so there are two different IP address ranges for two different subnets. Now within that, you can see there are two different instances. Now this instance can't communicate with this instance even though they are within the same VPC if there is no connection established between these two subnets as well. If firewall restricts, they won't be able to communicate. If firewall doesn't restrict anything, if it is just a simple VPC with two different subnets, even though they are private, they will be able to communicate with each other because they are within the same network. Now, what's the difference in GCP? In this case, VPCs are regional, but in GCP, a VPC network is global. That is, when you create a VPC, the VPC is spread across all the regions which is available in GCP. That is, if you create a VPC, in this case, let's say this region is only North Virginia, this VPC is only in North Virginia. If you create any resource, it will only be created within the North Virginia region. But in GCP, if you create a VPC, you can create any number of subnets within all of the regions that GCP provides. If there are 20 regions, this VPC will be spread across the 20 regions. Now, for each of those regions, you can create subnets and you can launch resources within them. And when you launch resources within the subnets, that basically means those resources are within this particular VPC. So resources across multiple regions can communicate with each other because they are within the same VPC. That's the major difference in the GCP's architecture compared to the AWS one. AWS one is restricted to the region, but GCP is basically global. Now, within here, you can see there are two different regions, but VPC is global. Now, in two different regions, there are three different subnets. In region 1, there are two subnets. In region 2, there is one subnet. And within region 1, there are three different zones. Region 2, there are three different zones. Now, what I'm trying to communicate here is, as there are three subnets, if there is a computer engine launch within this subnet and there is one more in this subnet, they can all communicate with each other even though they are in different regions and different zones, because that doesn't matter. They are all within the same VPC network, right? Hope this is clear. So now we have a GCE, that is an instance here, a virtual machine here, another one here, another one here. Now all of these three can communicate with each other even though they are in different zones, even though they are in different regions. Again, subnets are across zones, so zones also don't matter when it comes to a subnet. Zones are basically like VPCs, they are fixed to one particular region. But again, even though they are across different regions, they can communicate with each other because VPC is global. Hope this is clear. This is all I wanted to convey here, because it'll be easier for us to understand when we have a comparison, because many of you would have known about AWS or just GCP before, but now with this comparison, you can see what they offer and what they offer. So you can clearly see a difference over here. Now, Moving further, again, how does a VPC work though? We understood the network, we understood that it's an isolated network, we can launch resources within that. There is something called a subnet. Again, we'll come back to that later. But how exactly does it work? How does it isolate? Now, that's what we are going to talk about. If you can think of a VPC that same way you would think of a physical network, except that it is virtualized within Google Cloud. A VPC network is a global resource that consists of a list of regional virtual subnets or subnetworks in data centers, all connected by a global wide area network. VPC networks are logically isolated from each other in Google Cloud. Logically isolated in the sense they exist in the same data center or exist in the same cloud platform virtually, but even though they are virtually available, they are isolated from each other. It's basically like if you run a virtual machine on your laptop, let's say on a Windows laptop, you run a Linux machine, or on a Mac laptop, I run a Windows on top of it. So now the Windows machine and the Mac operating system will be isolated. If you install something within the Windows virtual machine, it won't be reflected in your Mac operating system. It won't disturb it at all. They will be completely isolated. Similarly, in this case, they will be completely isolated. So here you can see, again, it's a similar example for GCP internet. There is VPC routing. If VPC routing allows an internet access to the virtual machines within the subnets, then it lets you access. For example, here internet access is provided to all of the virtual machines. Now there is one region, US West 1. Now VPC is covered, and there is another region, US East 1. In West 1 there is one subnet, in US East 1 there are two subnets, and here within this particular zone, US West 1A, there are two virtual machines. In subnet 2, in subnet 3, and there are three different zones, but there are two different virtual machines in subnet 2 and two different ones in subnet 3. But using VPC routing, and as they are in the same network, they can communicate with each other, and that's basically the point which I wanted to convey over here. Now, how does it isolate? It isolates by not letting basically any access coming from outside. VPC routing and firewalls decide what connections comes from outside or what connection go from inside. But you can stop connections from a particular range of IP address, or I can stop connections coming from a particular computer or a particular range of IP addresses. And using firewalls and VPC routing, we'll be able to do that. And by doing that, we can isolate or blacklist some IP addresses which will be harmful for the network. Right. So this is how a VPC works. Now, moving further, let's understand the very basics of VPC and then proceed. First of all, subnets, they are regional resources. As told, VPC in Google Cloud is global, but subnets are regional. Each subnet defines a range of IPv4 addresses. Subnets in custom mode VPC networks can also have a range of IPv6 addresses. Let's ignore IPv6 for now. Let's just have range of IPv4 addresses for now, because mainly we all use IPv4. Traffic to and from instances can be controlled with network firewall rules. Rules are implemented on the virtual machines themselves, so traffic can only be controlled and logged as it leaves or arrives at a virtual machine. To put it simply, you create a set of rules, but that rules is not an actual firewall. It's just a set of rules, but the rules are implemented within the virtual machine. So when a communication or a connection from the internet or another resource is coming to the virtual machine will check the rules if it should let this connection connect to it or not. If the firewall rules allow it, it will connect. If it denies it, it won't allow. So it is implemented over there. So now in the virtual machine, it will get logged that this connection was trying to connect, but it got denied. Now, using that, you can understand that your firewall rules have worked. And then resources within a VPC network can communicate with one another by using internal IPv4 addresses, internal IPv6, or external IPv6 addresses subject to applicable network firewall rules. So now the network firewall rules not only is applied to connections coming from the internet or connections going to the internet, it's also applicable for the resources within the VPC. Now, talking about that, if there is no permission for communication or any kind of connection from the internet or to and from the internet, but the instances, the resources within that particular VPC network can communicate with each other using the internal IPv4 addresses, or basically it's called a private IP address, right? We can use that. So these are basically the basics. I hope this is clear. Now, let's move ahead and look into VPC components. And there are various components, subnets, cloud firewall, routes. I'll also explain what is IP address insider, then also VPC peering, and finally we'll look into the demo. Now, let's look into subnets. Each VPC network consists of one or more IP address range called subnets. What exactly is an IP address range? It's basically from one particular range. That is, let's say you can make 255 IP addresses. That is one single range, and that range will have its own specific IP address terminologies. For example, let me just quickly show this. So this is an IP address, right? So now 54.92.0.0/16, this will become an IP address range. I will explain this later. I'll explain how an IP address range is formed. Now just assume it's an IP address range. A subnet is basically a sub network. That is, let's say within a VPC, you can create 6,000, let's just assume 1,000 IP addresses. That is, 1,000 different resources can be created within the VPC. So now, within that, if you want to isolate even further, if you want to create sub networks, even smaller networks within the VPC itself, you can create subnets. And subnets are regional resources. That is, if you want to create resources only for one particular region in US, then you can do that. One particular region in Europe, you can do that within the same VPC. Now, all of these subnets are regional resources and have IP address ranges associated with them. When you create a resource in Google Cloud, you choose a network and subnet. Whatever resource it may be, you need a network to create it, and to create that particular resource in a particular region, that region should have a subnet. If a region does not have a subnet, you can't create over that. That's what is the purpose of a subnet, because VPC is global. But if you want to create a resource within a particular region, then you'll have to mention it somewhere. And how do you do that? Using a subnet. Now, for resources other than instance templates, you also select zone or a region. Now, zone or a region is within that particular region. There are multiple zones. As we saw in the architecture diagram, there are various zones available within the same region. These zones are physical data centers, various physical data centers. The subnets are basically logically spread across all of these zones because they are regional resources, not zone specific resources. So keep that in mind. They are spread across all the zones. If you create one subnet, that subnet is more than enough for you to create resources within multiple zones. You can mention what zone you want and it will automatically take it out. Right? When you create an instance, you select a zone for the instance. If you don't select a network for the virtual machine, the default VPC network is used, which has a subnet in every region. If you do select a network for the virtual machine, you must select a network that contains a subnet in the selected zone's parent region. That basically means without a subnet, you can't create a virtual machine and run it. You need a subnet in a particular region, and if you want to run it in a particular zone, in a particular region, then you need a subnet for that particular zone and region. That's basically it. Now coming to the next part, VPC network supports the following subnets. One is IPv4 only, which is a single stack. This only allows IPv4 subnet ranges. There is also an IPv4 and IPv6 double stack subnets. So this basically will provide us an opportunity to use both IPv4 and IPv6 ranges. A single VPC network can contain any combination of these subnets. A single VPC can have any number of subnets, and those subnets can have just a single stack, which is IPv4 range, or double stack, which is IPv6 and IPv4 both. Now, here are some valid IPv4 ranges which I wanted to show you guys. So now 10.0.0 is valid, 172.16.0.0 is valid, 192.168.0.0 is also valid. So /8, /12, /16, that is side annotations that we'll come back later. Now, these are the valid IPv4 ranges. Even this is valid, but it's a shared space with RFC. Again, if you want to learn more about particular address ranges, you can go ahead to these links, and to go to these links, you can just open the subnet documentation. And then 192.0.0.0/24 is also a valid IP address, and these are all private IP addresses, not public. Public IP addresses will be completely different. From these, it'll get associated, or GCP will create it for you if you need a public IP address, but it won't be within this particular address ranges. right? Hope this is clear. Now, next topic is cloud firewall. But before moving on with cloud firewall, let me take you guys through the IP address and CIDR. Now, I've taken an example here, 54.92.31.18 or 54.92.31.18. Now, we are converting all of these numbers or digits to basically their binary component. Over here, you can see 54 can be written as 00110110. Similarly, 92, 31, and 18. All of these can be written in the binary format. Now, how do you define a IP address range? This is one single IP address, right? Now, if you want an IP address range that starts with 54.92 and can have any number over here, that is over here. For example, there are two different addresses. One is a network address, which basically defines the the first 16 digits of your network, 16 bits of your network, because these are individual bits, right? You can see one single number is 1 byte and they have 8 bits, and the first 16 bits are network address and the last 16 bits in this case are the host number. Now, the host number over here, network address, is equal to 54.92.0.0/16. Why 16 here? Because the first 16 bits can't be changed. They are fixed. You can't change 54.92 at all because they will be fixed. And so 0.0 basically means these can be interchanged. This can start with 0.0, 0.1, 1.1, 1.0. It can keep going till this. So the address range for this would be 54.92.0.0 to 54.92.255.255. So this is the address range that can be formed. Now, coming to the number of hosts, 2 power 16 minus 1 is equal to 65,535. So now what does this mean? Number of hosts means how many resources or how many different instances or other resources like a database, everything needs an IP address. So now how many addresses can be launched within that VPC or subnet is calculated using this particular simple formula. So you can take the subnet mask over here. So 54.92.0.0. So now 16 bits is the host number. So now you will have to take 2 power 16 minus 1. But what if it was 54.0.0.0/8, then you will have to take 32 minus 8. That will give you basically 24. Now it will be 2 power 24 minus 1. What if it was 54.92.31.0/24? In that case, first 24 bits can't be changed, last 8 bits can be changed. Now, again, you can subtract 32 minus 8. So now that will become 8 bits. So it will be 2 power 8 minus 1 would be the number of hosts. Hope this is clear. This is how you get an IP address range. You use the CIDR, that is the classless interdomain routing. So you use CIDR in order to form this. So 54.92.0.0/16 basically represents 54.92.0.0 to 54.92.255.255. This is the IP address range that it forms. Okay, so hope this is clear. So I just wanted to explain this so that it gets easily registered because we just completed subnets. Coming to the next topic, which is cloud firewall. So now Cloud Firewall is a fully distributed firewall service with advanced protection capabilities, micro-segmentation, pervasive coverage to protect your Google Cloud workloads from internal and external attacks. So basically, it's a regular firewall, but on Google Cloud. Every single cloud platform provides a firewall. Without a firewall, you can't have a cloud network successfully or running without having any attacks. Firewall rules is what decides what connections can come in, what connections can go out, what IP address ranges can you blacklist, what are whitelisted. If you just want to access that particular VPC or network from your laptop, you can just provide your IP address as a particular range, and it won't allow access from any other computer system, or it won't allow access from any other network, right? So that's how firewall comes into play. It's a regular firewall but hosted on Google Cloud. Over here you can simply see external internet. Now over here access is available for VM1. Over here access is not available for VM2. Now network tag allow inbound, so that basically means inbound traffic is allowed. Inbound traffic from the internet is allowed, but here we haven't provided that. This is server, this is client, but there is no possibility for them to have internet access. Over here you can see they can communicate with VM1. VM4 can communicate with VM3, VM4 can communicate with VM1, but they're not able to communicate to VM2 because it only has an external IP address. It does not allow access from anywhere, not from the internet, not within the VPC network as well. So now firewall rule over here, direction ingress, allow TCP connections can come from every single IP address. That basically means the internet. Targets allowed, allow inbound, priority 1000. And there is another firewall rule, source tags client and server. So access can only, so basically the requests can only come from the clients, and target will accept connection requests only from clients, and vice versa. Internet access is not possible. So these are the two different firewall rules they are talking about over here, and it gives a clear depiction of how firewall rule works. For this virtual machine, we are allowing external access from the internet, so it is allowing. But for the other virtual machines, we are not providing access from the internet. That so over here, internet access is not connect. It's not basically connecting to virtual machine 2, and also virtual machine 4 is not able to connect to virtual machine 2 because it doesn't allow any kind of access. But virtual machine 3 and virtual machine 1 are responding to virtual machine 4's connections. Now, VPC firewall rules let you allow or deny connections to and or from virtual machines in your VPC network. For example, that's what is discussed here. Virtual machine 2 has denied connections from every virtual machine over here. So whatever virtual machine tries to connect with it, it won't let it connect because it has denied using the firewall rule. So that can also be done. Enabled VPC firewall rules are always enforced, protecting your instances regardless of their configuration on operating system, even if they have not started up. That basically means if you already created a firewall rule, even though you create a virtual machine and it's running or it's stopped, or you create a new virtual machine, all the rules will be enforced immediately. Even though your virtual machine is just starting up, even then it won't allow any connection request or any kind of request from the IP addresses or the virtual machines you don't want connections from, right? Now, every VPC network functions as a distributed firewall. While firewall rules are defined at the network level, connections are allowed or denied on a per instance basis. To put it simply, the firewall rules are applicable for the entire VPC, but the rules are actually enforced on a per instance basis. That is, for example, when a connection request is coming to a particular instance, that's where the firewall rule comes into place. The instance checks the firewall rule to see if this particular instance should be allowed, if this particular connection should be allowed. If not, it won't allow. So that's what they are trying to explain over here. Also, you can think of the VPC firewall rules as existing not only between your instances, but also between individual instances within the same network. So it's not that your instances connecting with other networks or the internet is the only use case here. It's also between, if you have two different virtual machines or instances within the same network, you can basically decide if they can connect with each other or not by creating a firewall rule. So yeah, that's basically firewall rules. Hope that is clear. Now coming to routes. Routes is another important concept in VPC because it decides or defines the path between your network and the virtual machine. So what does it define? It defines the network traffic. If a connection is going from a virtual machine to the internet, the traffic is going from virtual machine to the internet. If there is a connection coming from the internet to the virtual machine, the traffic is inbound, right? So how that is defined? That is defined using a route. A route says from which source to which destination that a particular network traffic goes from. For example, here it defines paths that network traffic takes from a virtual machine instance to other destinations. These destinations can be inside your VPC itself or the internet. Subnet routes define paths resources like virtual machines and internal load balancer in a VPC network. Using subnet routes, you can basically define paths for virtual machines or load balancers. That is, if a connection going to a virtual machine should actually first go to a load balancer, or if a virtual machine can connect to another virtual machine, or if that virtual machine can deny this, and that paths, those routes, every single route is decided by the root category. So now using this, you can define anything. For example, if you want to provide a particular subnet internet access, then you will have to connect it to the internet gateway. So now how do you define that route? Using routes. So in routes, you'll have to mention that this particular subnet is attached to an internet gateway. So any resource created within the subnet will directly have internet access. But if you don't connect an internet gateway to a subnet and you create a resource within it, it can't connect to the internet. And yeah, so in that case, you have not defined the route for it. This is where routes come into play. They are really important. They are basically another building block, a very basic building block. Without it, you can't do anything. Even if you're not basically using it or by creating them by yourself, it is already there. You will have to use routes. Without a route, you can't work in a network, right? Now, what are the different route types? One is system generated default routes. One is, for example, when you create a subnet and you allow access from 0.0.0.0/0, that basically means the internet. The default route would be, the next hop would be default internet gateway. When you're using a default VPC, there will already be a default internet gateway. There are subnets for every single region, and every single region will have its own internet gateway. So again, an internet gateway applies to the whole VPC network. So when you create one internet gateway, it is already applicable to the entire VPC network. That basically means it's global, and you can connect all of those subnets to this particular internet gateway if you want internet access. If you don't want internet access to a particular subnet, you don't have to create a route to the internet gateway. Simple as that. Now, subnet route created automatically for each subnet IP address range. That is, when you create a subnet, again, you will have to provide an IP address range, like how we discussed before. For example, 10.1. Or 10.0.1.0/24 is an IP address range. So you will have to provide an IP address range which doesn't coincide or which doesn't overlap with other IP address ranges within the same VPC, right? Okay, hope that is clear. So this is VPC network, forwards packets to virtual machines and internal load balancers. This is within the VPC. It can connect to other virtual machines. It can connect to other load balancers using this particular thing. And it also applies to the whole VPC network. Again, if it applies to the whole VPC network, that basically means it is global as well. There are custom routes which you can create by yourself. One is called a static route, forward package to a static route next hop. It's pretty simple. You can create your own route, and you can put the next stop. Next stop basically means the destination through where it has to go. So now in the next hop, if you want to connect it to a NAT gateway, you can connect it to a NAT gateway. You can connect to an internet gateway, or the next hop could also be a different virtual machine. If your route take you to another virtual machine for a connection, that can also be done. Now, there is also a dynamic route, destinations that don't conflict with subnet routes or static routes. Peer of a BGP session on a cloud router. BGP is basically border gateway protocol. So there is a connection between your cloud network and your on-premises network, right? So now these routers, cloud routers are created by cloud routers within the VPC network. And whenever a session is running, which is connecting to an on-premises network or external VPC, in that case, you can use a dynamic route. It will automatically change to that particular resource, which is in basically outside of the VPC network. Because right now we are just talking about the connection within the network or connecting to the internet. We are not talking about connections to another network or connections to another VPC network or an on-premises network. For that, you can use a dynamic route. Hope that is clear. I've already explained IP addresses and CIDR. And the final concept we are going to learn before moving on with the demo is VPC peering. Now, to put it very simply, there are multiple VPCs. Let's say you create two different VPCs, VPC A and VPC B. Now there is a instance within VPC A and there is another instance within VPC B. Or let's consider VPC B has a database. Now the instance within VPC A wants to connect to the database within VPC B. So now to make that happen, there should be a connection between these two VPCs. and that connection is called VPC peering. VPC peering makes it possible for resources within two different VPCs to communicate with each other. To put it simply, it lets you build software as a service ecosystems in Google Cloud, making services available privately across different VPC networks. To put it simply, it's not connecting over the internet, it is connecting within the Google Cloud network, which is much more safer because there is no different route. It doesn't have to go to the internet and then come back to the database. It can directly connect to another network through the Google Cloud itself using the private IP addresses. Right now, whether the networks are in the same project, different projects, or projects in different organizations, it doesn't matter. If it is another VPC in Google Cloud, it doesn't matter if it is in your GCP account or in another GCP account or an external network as well. You can create a peering connection between two different VPCs within the same account or an external account as well. Now, with VPC network peering, all communication happens by using internal IP addresses. Internal IP addresses are again private IP addresses which are subjected within that particular IP address range which you have provided. For a subnet, as we already discussed, you will have to provide a range. Here, you have provided a range. You can see 10.0.0.0/16. There is another range over here, 10.8.0.0/16. These two subnets or two different subnets, but again they are within two different networks as well, network A and network B. You can clearly see that there is a routing table over here and there is another routing table over here. In subnet A there is a virtual machine, subnet B there is a virtual machine. Now this particular virtual machine wants to connect to this particular virtual machine. Then how is that possible? You will have to peer the network A and network B using the peering connection. That's basically it. Peering connection is pretty simple and the connections work normally. However, you connect instances within the same subnet and the same network. That's how you will connect to the other networks resources as well. Only difference is there is a peering connection enabled. You will just have to use the correct IP addresses to communicate with them. So that's basically it. Now let's start with the VPC demo. Now, starting off with the VPC demo, first let's understand what we'll be doing. So these are the main things we'll be doing, but I'll also be showing other elements. We'll be creating a network, we'll be creating a couple subnets, we'll be creating a couple firewall rules. One firewall rule I'll be creating just for SSH. That is when you are creating a compute engine. If you don't allow SSH access, you can't connect to the compute engine. To that particular instance, you won't be able to connect. Only through secure shell you can connect. And if you don't allow access to secure shell within your subnet, then those instances would not have access. That is, you can't connect to them. Next one is for HTTP because again, coming back to the instance, I created a simple website. We launched a simple web page by running a web server within the instance. So you can only see the web page if HTTP is allowed, port number 80 of the TCP protocol is allowed. If not, it won't be visible. So these are the things we'll be doing. Apart from that, I'll also show you VPC peering and many more things within VPC itself. But first, let's start with these. Now let me open the Google Cloud Console. So I've already logged in. I'm in the same project, my first project. Over here, you can see there are networks in the current project. So now you can also search for VPC over here. There's the first option, just click on it and you will be brought to the VPC dashboard. So now within VPC dashboard, you can see the first thing is VPC networks. And in VPC networks, there is already a network called the default network. Now let's click on it. Within the default network, you can see there are different subnets, default subnets for every single availability zone. So if you want to create a resource, you can simply use a default VPC in order to create these networks. If you want to create any resource within the VPC and want to create, let's say in US West 1, they already have a subnet for it. So you'll just have to select this particular subnet and launch a resource within this particular region, and it will get launched within the default subnet of that particular region. Hope this is clear. They do not have any static internal IP addresses. So let me just quickly explain what is a static internal IP address. Let's say you're creating an instance. If you're restarting it or you're stopping it and starting it again later, the IP address, the public IP address or the external IP address will change. To make sure it doesn't change, you have to reserve a static address and attach it to that particular instance. When you attach it to that particular instance, if you restart, if you stop and start, it doesn't matter, the IP address will remain the same. That's how this comes handy. Next, firewalls. There are no firewall rules over here. Yeah, so okay, there is one firewall rule which I created. So there are 4 different default. Over here you can see there are 5 default rules, and this is that HTTP rule which we created in the GCE module. And then routes, you can see every single subnet has a default route, and over here default local route to the subnetwork, default local network to the subnet route to the subnetwork. So every single subnetwork has its own default route. And if you click on a route table, you can see the description over here, network default. So this is the VPC which it's connected to. It's connected to the default VPC. Destination IP address. This is the destination IP address, and this is the IP address range of one particular subnet. And over here you can see virtual network. Next hop is the virtual network default itself. So for example, if you click on it, it'll take you to the VPC. We are already in the VPC. There will be now VPC network peering. Right now there are no peerings because there is only one network. Private service connection. Yeah, you can ignore these. These are extra features for us to understand the basics. That's not required, right? Okay, so now coming back to VPC networks, we've understood what a default network is. They've already provided you. There are 38 different subnets for all the regions which are available in GCP. Yeah, so there are also 6 firewall rules and everything can be seen here. Subnets in current project. You can see every single subnet within this particular VPC network. You can also select particular VPC networks to look at just the subnets within that particular networks. You can also remove this. It will show all the subnets in all VPC networks within basically your GCP. Now let's start with the first topic, which is creating a VPC network. It's quite easy. Just click on create VPC network, provide it a name. Let's say I'm providing it as VPC1 or VPC tutorial 1. As this is the first VPC, I'm just providing it like this. We can ignore that. VPC network ULA will IPv6. I don't need IPv6 range. I just want IPv4 range. Over here, subnets, custom automatic. It'll automatically create a subnet for you in all regions. Here you can clearly see, but I don't want that. I want to create my own subnets. I don't want multiple. I just want 2 subnets. Okay, number 1. Let me just name it VPC tutorial 1 subnet 1. Region, I want to create it in, say, US West 1. I just want IPv4. Now I'm providing the IPv4 range. This is my first range. You can see the address for this subnet. Inside a notation, use a standard private VPC network address range, for example 10.0.0.0/9. In this case, I'm providing 10.0.1.0/24. That basically means the first 24 bits are static, the last 8 bits can be changed. So it will have fewer combinations. That will be 2 power 8 minus 1 would be the number of hosts which can be hosted in this. It will be lesser than basically 2 power 16 minus 1, right? You can also create a secondary IPv4 range for this particular subnet, but I don't need it, so I'm just ignoring it. Private Google access. Set whether virtual machines in this subnet can access Google services without assigning external IP address. Yes. So this basically means resources within the network can access other resources without having to connect with the internet. So if you want that to be possible, then provide on. If you don't want that to be possible, that your virtual machine should be isolated and they can only connect to other resources using an external IP address, then go ahead with off. I'm just going to leave this on. Now this is done. Now I'm going to add one more subnet. I'm going to call it VPC tutorial 1 subnet 2, right? And this is going to be another region, US West 2 and IP. So one more thing, you can't give the same IP address range within the same network. It will throw an error because it will basically coincide with this. Over here, I'm going to provide it as 10.0.2.0/24 so that it does not coincide with the first subnet. Now that is provided. Again, if you want to provide on, you can provide it or off. So I'm providing it on and done. So now we've created basically we're creating a VPC, and within that we are creating two different subnets in two different regions. So that is provided, and these are IPv4 firewalls. If you want something automatically to be allowed, you can do that, but I'm just ignoring that. So again, dynamic routing mode, cloud routers will learn routes only in the region in which they were created. Global routing lets you dynamically learn routes to and from all regions within a single VPN. So I'm just going to go with regional. I'm not going to be use VPN or interconnect. Right now we're just going to stick to the basics, and yeah, and create. So you can also do the same in the command line. We are directly doing it in the console. Now here in the notifications, you can see create network VPC tutorial 1, and once it shows a tick mark, that basically means our VPC and subnets are created. So all subnets will be shown here as well once it's created. Now successfully created network VPC tutorial 1. Over here it's showing it's still creating, but let's look at the notifications. Yes, it's created. Let me just refresh this page, and it has been successfully created. You can see there are two subnets within it, and it's on custom mode and doesn't have any firewall rules. So now that's what we're going to do next. There are two subnets. Now let's start with firewalls. Now adding a firewall rule, the first rule I'm going to name it as VPC tutorial 1 SSH rule. So this particular rule only allows SSH, that is secure shell. If you have an instance launched within this particular subnet or within this particular VPC, those instances should be allowed for you to connect to. To make sure that happens, you need an SSH rule, because without secure shell you won't be able to connect to your instances. Or you can just open it on a browser, but again, even on a browser you would need SSH access. Without SSH access you can't connect to it. The network is VPC tutorial 1, correct. Priority, you can check priority of other firewall rules if you have any other firewall rules within your VPC. We don't have any other firewall rules as of now, and you can specify the order that a rule will be applied within the network. Rules with lower numbers get prioritized first. Default is 1000. To put it simply, if I create another firewall rule and put it as 900 over here, that particular rule will be prioritized before this. That it simply put, that rule will be checked first, and then this rule comes into play. For example, that other rule, let's say it has a lower priority. It has a lower number. That basically means it has a higher priority. That particular firewall rule says you cannot allow SSH access. If it says you cannot allow SSH access, then instances won't be allowed SSH access. And even though the next rule, which is this particular rule, says that you can allow access using SSH, doesn't matter. It won't even check this rule, because the rule which you already have given priority has denied access to the instance. So that's basically how priority works. Now, direction of traffic, ingress or egress, that basically means is it coming in or is it going out? That's basically how you can see. Ingress applies to incoming traffic, egress applies to outbound traffic, that is traffic going from your network to other networks or outside the network to the internet, or traffic coming inside, that is coming from another instance to your instance, coming from another subnet to your subnet, coming from the internet to your network. So those are all ingress, right? So it's ingress because you will be connecting to the instance, and that is incoming traffic to the instance. That basically means ingress, right? Action on match, allow. We are not going to deny it if we're not going to deny it, because if it matches, that is, if the rules match, if everything is fine, then it'll allow. Now, specified targets. Do you want to use specified targets? Right now I do not have any virtual machine running in these subnets, so instead of providing specified target tags, because I don't have any target tags to provide here, you will have to provide all instances in the network or specified service account. But I'm going to go with all instances in the network. Any instance launched within the VPC tutorial 1 network, in this particular case, this particular rule will be applied to all of them, right? Source filter IPv4 ranges. You can provide an IPv4 range. The IPv4 range I am providing is 0.0.0.0/0. Now, what does this mean? Connection request can come from any IP address in the world. It can connect from your laptop, it can connect from another laptop, it can connect from the internet, doesn't matter. It can connect from anywhere. That's basically what it means. If you don't want this to happen, you just want to connect it from a particular IP address range, then please provide that. If your company or corporate network has a particular IP address range, just provide that. Or if you just want to connect to the instances just from your personal computer, provide your personal computer's IP address over here. It won't allow connections from any other computer or any other network, right? For now, I'm just providing this. Next, protocols. Allow all. No, I'm not going to allow all protocol. As I said, this is an SSH rule, and for the secure shell rule, the port number is 22, and it's a TCP rule. SSH is a TCP protocol, and the port number which should be allowed for the SSH rule is port number 22. Hope this is clear. Now, that's basically it. And create. So we've created our first firewall rule. Now, let's go ahead and create another one. So now, within this itself, you can create multiple firewall rules. For example, let me create another one. So VPC, instead of SSH rule, I'm just going to write it as HTTP rule. Right? Same network, let me make it 900, or let me make it 1100, because I want SSH to be prioritized more than this particular rule, right? Again, this is also ingress, connections coming in, allow all instances in the network, and now again, the HTTP is also a transfer control protocol. It's TCP, and in this case the port number is 80, and that's provided. You can provide a single number, or you can also provide a range of port numbers too. Now create. Sorry, I've not provided the range. So 0.0.0.0/0, that basically means connection requests can come from anywhere in the internet. I already explained. If anybody in the internet wants to check out your website, they should be able to, and for that the source IPv4 range should be 0.0.0/0. Right, now create. Now we've successfully created two different rules as well. So now if you create an instance within any of these subnets, these firewall rules will be applicable, because those firewall rules are applicable to the entire network, and these subnets are part of the network. So hope that is clear. Now coming to routes, now we can see there are default routes, right? One is default route to the internet. When I gave it access to every single region, so this is basically the firewall rule which we created, which provided access to, which provided ingress access from the internet. So that basically means there should be a route coming from the internet to our network, and to satisfy that condition, you can see there is a default route to the internet. Next hop is default internet gateway, which is already available. Again, if you don't want to connect to the default internet gateway, you can delete these routes and add your own route by creating your own internet gateway, right? So now these are the routes, and over here you can see there is a default route to the internet. Now if you want your instances to be connected from the internet, that is from 0.0.0/0, that's what we were doing in the firewall. So if you want that to happen, in that case you should let this default route be, that is, it's connected to the default internet gateway. But again, it is connected to the default internet gateway If you want to connect it to your own internet gateway, then you will have to delete this route and then write your own route over here. You'll have to add a route. You'll have to provide it a name. Let's say route 1. Again, IP address range. And next is specify an IP address, specify an instance, specify VPN tunnel, specify a forwarding rule of internal TCP IP address. So that basically means if if somebody is coming from this particular IP range, should they be given internet access, or should they be redirected to a particular instance which is running in your VPC, or should they be pushed into a particular IP address which is running in your VPC? So the IP address could be a single instance, it could be a single load balancer which has hundreds of instances within it, right? So you can specify all of that in routes. Hope that is clear. Yeah, so now coming to VPC network peering, which is the last thing we were discussing about. Now we have two VPCs in our network, right? We have two VPCs in our network, so we can create a VPC peering connection. So now there is default VPC and then there is your VPC network. So I'm just going to provide it as VPC tutorial 1 peering connection 1. Right, my VPC network is VPC tutorial 1. The other VPC is default. So now I want to connect the VPC tutorial 1 to the default VPC to create a communication path. So that is privately these two VPCs can communicate with each other. So now if you want to connect to another project, that is right now we are in this my first project. If you have another project in your if you have another project in your GCP account, and if you want to connect to a VPC within that particular project, in that case you will have to click on another project and it will show up the VPC and you can click on that. But right now I just have the one project, so there is no purpose for me to connect to another project's VPC. So this is provided, it's IPv4. You can import custom routes or export it, or you can just leave it. I'm just leaving everything to default and I'm creating a peering connection. Successfully created peering connection. So now these two networks are connected to each other. Inactive waiting for connection to be created by default. To create an active connection, VPC network default needs to set up a connection to this VPC network VPC. So now what we'll have to do is create peering connection, continue VPC peer 2 default VPC tutorial 1 create. So now we are just doing the opposite of it. Now you can see they are active. That basically means now there is connection established from VPC tutorial 1 to default VPC. Also, there is connection vice versa. That is, instances within default VPC can connect to the instances within VPC tutorial 1 and vice versa. So this is VPC connection. Hope this is clear. Now coming back to VPC networks, subnets in current project. So now here you can see all the subnets are visible. And if you want to just look at subnets within one particular VPC, you can also do that. Okay guys, so now we are pretty much done with all the things over here. Now let's clean everything up, because again, as this is a free account, everything will be billed or taken from my credit. But if your free account has expired, if you're practicing GCP, so make sure you clean the resources as soon as you're done with whatever hands-on you're doing. Cleaning it or deleting it or just stopping it will reduce your billing costs. Now, going to VPC networks, you can delete the entire VPC to basically delete all the resources within the network. Let's click on delete. Now, this VPC has two subnets. It has two different firewall rules. Now, all of that will be deleted because we've deleted the VPC. But VPC peering connection is a separate entity. So for that, you'll have to delete them separately. So now this is done. So that's basically it. We are deleting the network and it will get deleted. So hope you guys understood from VPC networks. Now, coming back to the slides, we've looked into all of these concepts. We understood what is a network, what is VPC. We looked into the difference between the network architecture of GCP and AWS. And then we looked into other concepts, subnets, we looked into cloud firewall, routes, IP address, and CIDR, VPC peering, and more. Now, also, if you guys want to check out VPC, or if you want to check out other, if you want to explore other cloud platforms, you can go ahead and check the AWS tutorial, which is also available in Scala's YouTube channel. And or you can also check out the previous videos if you haven't watched them in this particular tutorial. This is a 5-part series. Now, all of those videos are already available on our YouTube channel. You can go ahead and check it. Now, hope the demo was clear, how to create a VPC, how to create subnets, how to create firewall rules, and the concepts. So that's basically it for today. And this brings us to the end of this tutorial series as well. We've looked into 5 different concepts. So we started off with the introduction, where we created the GCP account. Then we looked into the Google Compute Engine, and then we looked into persistent disks. Then we looked into cloud storage, we looked into cloud databases, and finally we are looking into virtual private cloud, which is the networking concept. So we've covered 4 different domains. One is the compute domain, one is the storage domain, one is the databases domain, and also the networking domain. So these are the basic and integral services in GCP. So make sure you learn these, go through all the tutorials, try to do the demos along with me and understand it. These are the basic ones. And if you want us to make any other tutorial on any other topic, if you want us to do or basically show you guys a project in a particular concept, or in GCP or Azure or any other DevOps concepts, please leave it in the comment section below. We will try to come up with new videos that you guys like. Right? So thank you so much. Meet you in the next one.